Hey guys, welcome to the Math Base. Do you know the answer to these problems? Sine 45 degrees, cos 30 degrees, and tangent 60 degrees? Pause the video right now if you want to try and work them out before seeing the answers. Okay, so if you use the special triangles, these would be the answers. How did you go? If you don't know how to do this yet, then please check out my video on special triangles. Link is in the description. So this is great and all, but it only works for acute angles. What about obtuse angles? What about reflex angles? Do you know how to work out the sine of 120 degrees? What about cos 225 degrees or tangent 330 degrees? They are much bigger angles, so we're going to need more than just special triangles. We need symmetry properties. Symmetry has something to do with reflections and references. Let's see this in action as we work out sine 120. Just taking the top half of the unit circle, acute angles will be in the first quadrant, while obtuse angles will be in the second quadrant. So the point made by 120 degrees will be around here. Let's call its coordinates x and y for now. We don't know what they are, but we know its relation to cos and sine due to its axes. X gives us cos 120 and y gives us sine 120. If you want to learn more about these relations, then have a look at my videos on quadrantal angles and sine and cosine. I've linked them in the description. Since we're after sine 120, we just need to figure out the y value, right? This is where symmetry comes in. We need an acute angle. So firstly, reflect this point over the first quadrant. Since it's reflective, the acute angle made here is the same acute angle made here, which is 60 degrees. This is known as the reference angle of 120, and this is super important. Reference angles are always acute and always measured from the x-axis. A very common mistake students make is measuring it from the y-axis, so watch out for that. Based on the axes relations, working out sine 60 degrees will give us our y value, right? Feel free to pause the video right now if you would like to work them out before I do. Okay, so using the 60-30 special triangle, we find the y value to be root 3 on 2. I hope you got it right. Since both points share the same y value, we can conclude that sine 120 also equals root 3 on 2. Done. If you like, you can do something similar for the x value, but just bear in mind its signage. Cos 120 is on the left side of the graph, so the x value would be negative. Okay, let's try cos 225. Focusing on the bottom half of the unit circle, the third quadrant takes angles between 180 to 270, while the fourth quadrant takes angles between 270 to 360. All of these are reflex angles, so the point made by 225 will be around here. Subtracting 180 from that gives us our reference angle, 45 degrees. Now remember, we want cos 225, which is the x value of our point. So using our reference, let's work out cos 45 degrees first. As usual, pause the video right now if you want to try working them out before I do. Okay, so using the 45 special triangle, cos 45 will equal root 2 on 2. I hope you got that. Now we just need to compare the points. Anything we find from the first quadrant always yields a positive value. But our point is in the third quadrant. X is negative over here simply because x values are always negative on the left side of the graph. And since it is reflective, it uses the same number from our reference point. So the x value is just negative root 2 on 2, which means cos 225 is negative root 2 on 2. Done. And of course you can do something similar with sine 225 by working out sine 45 and reflecting its value back down. The y value is going to be negative since it's below the origin. So to summarize, all you really need to do is figure out the reference angle, work out its cos or sine value, then determine whether or not your answer should be negative or positive, based on the quadrant it's in. Let's make use of this and apply a slightly shorter method with tangent 330 degrees. 330 degrees is in the fourth quadrant, meaning you can't minus 180 to get an acute reference angle. You'll need to measure it from 360, giving us 30 degrees. Tangent can be found from sine dividing cos, but do we have to work out all this stuff? No. Tangent 30 and 330 are both worked out the same way, so we can just skip the sine and cos stuff and start working on tangent 30. Using the 60-30 special triangle, we'll find tangent 30 to be root 3 on 3. But is it positive or negative in the fourth quadrant? Since sine divides cos to give us tangent, that's the same as saying y divided by x on our point. No matter what the values of x are, it's going to be positive on the right side of the graph, and y is going to be negative below. So dividing such values will always yield a negative result. This means tangent 330 degrees is negative root 3 on 3. And that's it. So while this video provides a good understanding on how to do this, it's really quite tedious to do it this way, unless you want bragging rights. Some of you may find the cast tool more useful, so I'll provide a link in the description on how to do that when it's out. It's much quicker and more practical. However you decide to do them, you'll need to use symmetry properties to work out trigonometric ratios for obtuse and reflex angles. In other words, you'll always need the quadrant and the reference angle to solve these problems. Keep in mind that if you want to use symmetry properties to work them out by hand, their reference angles will either be 30, 45, or 60 degrees, unless you are provided with values for other acute angles. There was a lot to take in here, but you did really well making it to the end. I do hope this video has helped you, and if it has, please like the video so that others can be helped by it. If you have any questions or suggestions for new videos, please let me know in the comments below. And don't forget to subscribe and ring that bell so you know when the next video comes in. Thanks guys, see you in the next one.